Hello, I'm Mike Walker. I've been working around SMI and SMI-S for about 20 years in various capacities, including doing some technical editing of SMI-S 1.8.0. Recently, I've been working with a Python package called pywbem. Pywbem provides client software for accessing Webm servers like SMI-S servers. Pywbem isn't the only tool you can use to access Webm servers, but it is one that is actively being maintained, which is why I use it. Pywbem has the ability to mock Webm servers. So I've created a set of mock SMI-S 1.8.0 servers. This presentation will tell you how to get these mock servers and install them on your system, including the necessary Python and pywbem code to use it. So let's get started. So we will begin and look at what we're doing here. The purpose of this presentation is to provide information on installing code and data in order to run a set of SMI-S 1.8 mock Webm servers. The presentation describes the process for Windows, but there are similar steps for installing code and data on Linux. There is also some discussion of quick start guides, which are pywbem CLI scripts for accessing important data from the Webm servers that support SMI-S 1.8.0. But the details of the guides will be addressed in other presentations. So the first thing we're going to do is install Python virtual environments, pywbem, and pywbem tools. Then I'll talk about installing the mock environments for SMI-S 1.8. And finally, I'll wrap up by describing the quick start guides. So installing Python 3, Python virtual environments, pywbem, and pywbem tools. So the first thing we're going to do is install Python 3. So you go to https://www.python.org/downloads. You download the latest version of Python 3.8. I've installed Python 3.8.5. There's probably a later version. You run the Python exec, and when you run that exec, they'll ask you to check install launcher for all users, and you want to check that. They'll ask you if you want to add Python 3.8 to the path, and you want to check that. And then you click install now. To verify the installation, check the version from the command prompt by typing in Python --version. So let me first show you. This is a page you get when you go to that address, and there's the button you push to do the download. So if you check the version, and I did this, I ran Python --version, and sure enough, it told me I installed Python 3.8.5. Finally, we recommend downloading the documentation on Python, especially if you plan on doing any programming. And you'll get documentation on Python, and it comes in a variety of stuff, including tutorials. So after we've installed Python, the next thing we want to do is install Python virtual environments. And this is actually going to involve installing two things. The first is virtual env. You do a pip install virtual env. And when you do that, you're going to get a set of statements on what was installed. You'll probably also get this, you need to update your pip version, but that's neither here nor there. And the next thing you want to do is install a virtual environment wrapper, in my case for Windows. And the reason you want to do that is it makes using the virtual environments a lot easier. And you'll get a lot of statements on what was installed when they installed the wrapper, and you're good to go. So once installed, you can define your virtual environments and initialize their directories. And you define a virtual environment with the mk virtual env command. The -a says you want to identify a a directory where you're going to have data that you're going to use. And then you name the virtual environment, in this case, Mocks. So this creates a virtual environment called Mocks using the directory /devenv, devenv. So when you do that, it will define the virtual environment, give you some messages, and then it'll drop you into that virtual environment. That's what this indicates over here, Mocks. We defined it and it dropped us in the mock environment. Now, to see what environments you have defined, you can just type in work on, and it will list the virtual environments that you have. To work on a particular virtual environment like Mocks, you would say work on Mocks, and that would drop you into the virtual environment. So let's go look and see what that looks like. First, I issued the work on command to see what virtual environments I had, and I have 4 virtual environments. But the one that we're going to be using in these demos is Mocks. So we'll enter work on Mocks, and it drops you into the mock environment. So we've now set up a virtual environment. Now, in my next recommendation is you install pywbem in a virtual environment. That way you know what you've got in that virtual environment. So we go to the virtual environment, work on Mocks, and then we pip install pywbem. And that's all you have to do is say pip install pywbem, and you'll get the latest version of pywbem. And it will give you a whole bunch of messages on what actually got installed. And when you've done with that, you're back in your virtual environment and you have pywbem installed. Now, for documentation on pywbem, in this case, the installation, you can go to a web page and it will tell you about installation. You can back up to a higher level and see other documentation of interest. So that gets pywbem installed. And the next thing you're going to want to do is install pywbem tools. Pywbem tools is where the pywbem CLI is. So again, you go back, work on Mocks, and pip install pywbem tools. And you get another bunch of messages on what gets installed, and this goes on for a couple of pages, but we won't deal with those details. And finally, you want to get the docs for pywbem tools, because this will tell you the commands you can issue from the pywbem CLI, among other things. And when you go to that page, you'll go to this document that gives you the latest documentation on the tools. Now, installing supplied Mocks. This is the main thing you need to get out of this presentation. First, you go to the repo on GitHub of the mocks, and the address is shown here. It's https://github.com/farmermike252, that's me, /SMIS_mocks. Now, before you clone it, you're going to need to initialize a directory where you want the mocks to be put, assuming you want to download the mocks, or you can just look at the mocks on the GitHub site. So you do git init on a directory, and then you clone the repo to your system. That's with a command that is git clone https://github.com/farmermike252/SMIS_mocks.git, and that will clone the mocks down on your system. Now, if you have any comments or questions on anything in the SMIS mocks repo, please open an issue and I will try to respond in a timely fashion. Now, once you've installed these on your system, if you want to use them, you want to copy 3 mock files of the profile you want into your virtual environment. Now that means copy them into in my case, the dev.env directory that I defined on an earlier slide. And you can go to the virtual environments. They work on mocks. Start and save your mock. Now in my case, what I'm showing here is I'm issuing a pywbem CLI command. I'm saying -m array mock load.py. This is a Python program that will load the mock. And once I've loaded it, I want a connection save it under the name array mock. And the reason for doing that is it shortcuts connecting the next time I want to connect. Once it's saved, it can be started. And you do that by issuing the command pywbem. The -o table is for saying the default output should be in table format. And then -n for naming the mock, array mock. Now, there's one last step I'm going to have you take. The actual saving of the mock needs to have a command issued. So you issue an instance get sim_system $?PL for property list, creation class name, and name. And when you do all that, here's what you get. So I did the initial command identifying the mock load program and the connection save as array mock. Then I connected to the array mock with the default output of table, and I get a prompt saying I'm good to go. But then I say instance get sim_system with property list of creation class name and name, and you see there's activity going on. They're loading class definitions into the mock, and then they're loading instance definitions into the mock. And finally, they're done loading the instances. And this, for the array mock, will take 20 to 30 seconds. Now, that's why I have you do the create instance. Once that 20 or 30 seconds is executed trying to do the get instance, it loads a lot faster the next time you go after array mock. So that's why we did that. So it turns out there are 4 systems on the array mock. We pick one. In this case, I picked the first one, and it gives you the creation class name and name of the mock, or name of the system. So that covers that. And that leads to the quick start guides. SMIS is 2,516 pages of reading, spread across 8 books, plus it references another 14 or so DMTF profiles, which amount to another 660 pages of reading. So the question is, where do you start? Well, we've come up with a series of quick start guides that are designed to help you get started by illustrating how to find useful information in mock servers, mockups of SMIS server implementations. The quick start guides don't illustrate everything in the 3,176 pages, but they give you a head start at finding some important items in SMIS. We currently have quick start guides for the interop namespace, which tells you what is an interop namespace and what's in it and what you learn from that. There's a quick start guide on performance. Where do you find performance information? And what do we keep performance on? That's all in there. Capacity information. Where do you find storage capacity for an array? And that includes raw storage, it includes allocated storage, and finally it includes storage that is exposed as storage volumes. Hardware information. Now this is hardware, you can sort of think like FRUs. There are pieces of hardware that make up the array server. The product information, where do you find product information in an SMIS server? And finally, software information, where do you find what level of what software do you have in the system? So with that, we're going to stop here, and I want to take you to my GitHub site and show you what's on that site. So this is the GitHub site. Firmware Mike 252 SMIS_mocks. And what you're going to see on this site is a set of directories. Each directory contains a mock. This is an array mock. This is a NAS head mock. I'll get to the quick start guides later. There's a mock for a server profile and a mock for a Webm server profile. So we've talked a little bit about this. This is my site for where I keep and publish mock servers that I've created. Each mock is made up of 3 files: a Python program, an XML file, and an instance MOF file. The XML file is named org_profile name _ leaf list. Examples are SNIA array leaf list.xml and nashead leaf list.xml. The XML leaf list holds the leaf classes for a complete implementation of an autonomous profile. That is, all classes in the autonomous profile, defined in the autonomous profile and all of its component profiles. And this is based on all classes identified in SMIS 1.8. The MOF file is named MOF org_profile name instances.mof. Examples are mock SNIA array instances.mof and mock SNIA _nashead instances.mof. The mock files contain instance mocks for all the instances that are to be mocked. The Python program is named profile name mockload.py. Examples are the array mockload.py and the nashead mockload.py. The Python program is used to establish and name the mock. The program reads the class list for both the Webm server, profile, the SNIA server profile, and combines those lists with the list for the device profile, that is the array or the nashead. It uses a combined list to load class definitions in the mock. And then it reads the mock file to load the instances in the mock. Finally, the quick start guide that we've talked about before, but I want to show you what we've got in there. These are PDF files that include the commands, the commands I issue in the demos, and the output from the demos, and text that describes what we're looking at, the commands we use to get that information, and the output that is produced from the mocks. So the next thing I want to do is come up and show you what's in the array mock. And as I said before, there's a mock load program, there's a set of instance mocks, and then there's an XML file that defines all the leaf classes that you need to have to support a complete implementation. Now, my implementation in my mock is not complete, but this leaf list gives you all the class definitions you'll need if you would, as we expand on the mock. So the next thing I'm going to show you is the quick start guides. And here I'll tell you that I've got the presentation I just went through uploaded here as well. And then there's PDFs of the demos. And there's a README that explains what's in each of these. We've sort of been through this information in the previous presentation. And then the tools used for the quick start guide, which is basically the pywbem CLI. And you can get documentation on pywbem CLI off this link. And then I identify the mocks that we have implemented. Now, we are planning to do a fabric mock and switch mock, but we haven't done those yet. We chose to do workups on SMIS 1.8 versions of these profiles to illustrate differences between 1.8 and 1.6.1. We don't mock everything that's new in 1.8, but we do highlight some key changes. Like the DMTF Webm server profile is new in 1.8. There's a bunch of new indications that are new since 1.6.1, and there's an advanced metrics in the performance in video, and the performance video will explain what's new in the advanced metrics. So that's the summary of what you need to get going on the mocks.